The second part of today is average rate of change, which when we did linear functions, this was called slope. So it's very similar. The reason it's not called slope anymore is because, like on this example, from here to here, you have a positive slope. It's going up. But then over here on this side, from here to here, it's going down. So if you were to say, well, what's the slope of this equation? It would be different in different places. Okay, so for quadratics, it's called average rate of change. Sometimes we simplify that to a rock, average rate of change. You still solve it the same way. So we're still going to use m equals y2 minus y1 over x2 minus x1. Okay, so this is a little bit of review with just a hint of new stuff. All right, so for our first example, we have Wile E. Coyote is catapulting a boulder off a cliff to hit the roadrunner. Let t represent the number of seconds that the boulder catapults off the cliff, and h of t denote the height of the boulder in feet above the base of the cliff. Ignoring air resistance, we can use the following formula to express the path of the boulder. So here's the equation for this graph right here. Now it says calculate the average rate of change for the function over the interval 1, 3. So here's the part that's a little bit different. I told you before that maybe from here to here you have a positive slope, but then here to here you have a negative slope. So it's different on a quadratic. They're always going to give you an interval, meaning they're going to tell you find the slope between these points. Okay, and these will always, always, always be your x values. Like this is your first x, this is your second x. All right, the way I like to look at it is I have 2 points and I always stack them. These 2 numbers are my x's, and then I got to figure out what y is. All right, so if you have a graph, you could just go over to 1 and up, see where it is, and then over to 3 and go up. But it's a little hard to read this graph, so I'm going to do it in the calculator. Now, you could do each one individually. So you could type this equation and plug in 1 for t and see what it equals, and then put that number here. And then you could plug in 3 for t and see what it equals and put it here. The other way to do it, when you get your graphing calculators back, or if you use an online graphing calculator, is go to y equals and type your equation. So I'm going to type negative 16, and it doesn't matter that it's t, I'm just going to use x squared plus 24x plus 160. All right, now I'm trying to find these points here, so I'm going to go to the place in the calculator that gives me points, which would be my table. So I'm going to hit second graph to go to the table. Okay, so when x is 1, y is 168. And when x is 3, I gotta go down a little, y is 88. All right, so now I have my points. Now I can use my formula up here. All right, and I know in my class we talked about this. You can do the top minus the bottom or the bottom minus the top, as long as you do it the same way for both your y's and your x's. And you have to start with y on top. All right, so let's do it this way. Let's do 168 minus 88. So I'm subtracting my y's. And because I did top to bottom, I got to do top to bottom over here. 1 minus 3 on the bottom. All right, and then I'm just going to type that in the calculator. Let's see, this should be 80 over negative 2, which simplifies to negative 40. There's your rate of change between 1 and 3. So between 1 and 3, so this section right here of our graph has an average slope or an average rate of change of negative 40. All right, here's another way they could ask you this. They might not have a graph, all right, but you would still set this up the same way. So it says calculate the average rate of change of the function, this equation over this interval. And remember, this is always going to be your x values, always. So I'm going to list my 2 points. I have 2 comma something and 12 comma something. All right, and again, you can plug in 2 for x, see what it equals, put that number here. And then plug in 12 for x, figure out what that equals and put that number here. Or you can do it in your calculator. So I'm going to go back to y equals. And I'm going to type my equation. So, oops. 2x squared plus 4x plus 1. And then go to the table. All right, when x is 2, y is 17. When x is 12, y is 337. All right, now we're going to use slope formula. So it doesn't matter. Let's do this one from the bottom to the top. All right, always start with y's. So I do 337 minus 17. And I started on the bottom, so I have to start on the bottom for x. 12 minus 2. On top, I get 320. On bottom, I get 10. Simplify that or divide that, and you get 32 as your average rate of change between those points. All right, number 9 looks a little bit different because the interval is written differently. Also, we haven't really talked about this. This equation is in vertex form instead of standard form. So it looks a little different, but it's still a quadratic because it's being squared. All right, this is trying to confuse you, but don't let it. It's still giving you your x values. So the first x is 0 something. The second one is 2 something. Okay, so I'm going to type this equation in. Parentheses x minus 2 squared plus 1. Go to my table. All right, when x is 0, my y is 5. When x is 2, y is 1. All right, and then it doesn't matter top to bottom, bottom to top, as long as you do it the same on both sides. Let's do 5 minus 1 over 0 minus 2 gives us 4 over negative 2, which equals negative 2. All right, let's do one more just to be sure. All right, our points are going to be 6 comma something and 8 comma something. Plug this equation in. Go to y equals x squared minus 8x plus 12. Go to the table. So when x is 6, y is 0. When x is 8, y is 12. All right, let's do it this way. Bottom to top. Doesn't matter either way. 12 minus 0 and 8 minus 6 gives us 12 over 2 or 6. All right, on the back of this page, you can cross out that top portion. We haven't done that yet, so don't worry about those first 4. You should be able to do the 4 practice problems on the bottom. One thing I would tell you to be careful with is on number 8. Let's look at number 8. your points start here. So you have a -3 comma something and then 3 comma something. So whatever you get for your y's, you're going to subtract on the top. Now on the bottom, let's say you did bottom to top. If this is 3 minus a negative, so it's 3 minus a -3, minus a negative is the same as adding. So be careful with that extra negative. Otherwise, you should be good to go. Good luck.